Hello, geometry classes. We are going to work today on finding areas and perimeters of regular polygons. So we're going to introduce a new vocabulary term for a circle. So we have some background here. Notice it's in a thinking bubble. So that means you do not have to copy it onto your paper unless you would like to. So we see here a hexagon that's inscribed inside of a circle. And then in that hexagon, we see a triangle FED. And then inside of that triangle, we see two triangles. We see triangle EGF and we see DGF. So what we need to focus on here is this new segment inside of this circle that has a hexagon inscribed and a triangle inside of that hexagon right here from F to G. That's going to be an important segment as we find areas and perimeters of regular polygons. This is called the apothem from F to G. From the center of the circle, from the center of the polygon, to the segment of the triangle that connects two of the vertices of that polygon. So we have a new name here from F to G, that's the apothem. We have some old words here also, just remembering from F to E or from F to D, that's the radius of the circle. Okay, so now we're ready to move into our one theorem for today. How do we find the area of a regular polygon? So I can actually start with this second formula here so you can understand where the formula comes from that we're actually going to use, the simplified version. So here I have a hexagon. This applies to all polygons, but we're going to look at this hexagon as an example of why this formula works. So if I have a hexagon and I plot the point that's in the middle of that hexagon here and draw a triangle to the vertices and create one triangle here, we would call from here to here the apothem, and then this would be one of the sides of our polygon. So S stands for the length of the side of a polygon, and A stands for the length of the apothem. So if we look here at this formula, we can see how we can figure out the area of the entire polygon by taking one of these triangles that we can draw inside, and noticing that we could draw actually 6 triangles inside of this polygon. It has 6 sides. We could draw 6 triangles, all that look exactly like this. So we could go from center to vertex, center to vertex, center to vertex, center to vertex, and we would have 6 identical triangles. And each one of those triangles would have an area of 1/2 base times height, the base being S, the height being A. So 1/2 times A times S, that's the area of one of the triangles. Well, there are 6 triangles, which matches the number of sides. So one of the triangles 6 times will give us the area of this entire hexagon. How does that translate now into the simplified formula? Well, if you think about it for a minute, the number of sides times the side length would actually give you the perimeter. One of these sides 6 times would give you the perimeter of that polygon. So really all we have to do is the perimeter, which would be all of these bases of the triangles all added up, times the apothem, and take half of that. That's going to be actually 1/2 times all 6 of the triangle's bases times the apothem, and that will give us the area of this particular polygon, which happens to be a hexagon in this case. So this is the formula we're going to use. We're always going to find the apothem length, or we're going to find the perimeter length, and we'll plug into this formula to find the area of any polygon. All right, so guided practice 3. Let's take a look and see how this works. So in guided practice 3, we're given a pentagon. It is a regular polygon, we're told that. And this is the information they provide us. Anything you see in black is what they give us here. Now I've pulled out this black triangle, and I've added actually the letter X. They didn't provide that. I've added that in. I'm going to need to know the length of this piece here in order to find the perimeter. So this part of the triangle here, if I double it, will give me the side length, and I will have 5 of those side lengths. So let's go ahead and figure out the length of this X. So from this triangle that I've pulled out here, I always like to pull it out and label just the triangle parts. I'm able to figure out X using the Pythagorean theorem. So x squared plus 6.5 squared equals 8 squared. And we're going to solve for x now. Subtract 6.5 squared on both sides. Use your calculator to figure out what 6.5 squared is. Use your calculator to work out 64 minus 42.25. And use your calculator to take the square root of both sides to arrive at x equals 4.664. Since I'm going to end up rounding off to 2 decimal places, I'm going to carry this one more place past because I'm going to use it in a calculation that I want to make sure I'm not rounding too soon to limit my accuracy. So I will carry anything that's a partial answer, I will carry it 3 places past the decimal point, and at the end I'll round to 2 places past the decimal point. All right, now notice 6.5 is the apothem. So we already have the number for the apothem. So let's go ahead and now figure out our perimeter, and then we can move into the calculation for the area that will use that apothem. Okay, side of this pentagon will be twice whatever x is, and we already know x is 4.664. So we're going to multiply 4.664 times 2 to get the side of one side of the pentagon, and that gives us 9.328. And to find the perimeter, I'm going to take that side length 5 times, because the pentagon has 5 sides, and my perimeter is 46.64 units rounded to the nearest hundredth. All right, now I'm ready to find my area. Area is 1/2 times the apothem times the perimeter. Well, we were given the apothem, 6.5. So I'm going to plug in 6.5 for my apothem, and then we calculated the perimeter to be 46.64. So to work out my area, I'm going to multiply 1/2 times 6.5 times 46.64. Remember to key in 1/2 to your calculator. You will do 0.5 because 1 divided by 2 is 0.5. My area then of this particular pentagon will be 158.58 units squared. Next one. All right, guided practice 4 asks us the exact same question, but this time they give us just the side length of this regular decagon. It's a tengon. They don't tell us the measurement of the apothem. They don't tell us anything other than the fact that one of the side lengths is 7. Well, that makes finding the perimeter super easy. We already know the side length, so one of those sides 10 times, because there's 10 sides, gives us the perimeter equal to 70 units. All right, knowing the perimeter now, that's great. To find the area, we will use that perimeter, but we also have to find out what the apothem is. All right, so I'm going to take this one triangle out that I've drawn in. I'm pulling one of them out. Now remember, there's going to be 10 triangles, all exactly the same size inside of this tengon, and I've kind of sketched them in for you, and you can see that there are 10 angles here, central angles, that are all going to be exactly the same in those triangles. So we're going to have to take 360 degrees all the way around that circle, and we're going to have to split it into 10 pieces. 360 divided by 10 is 36. So for any one of these triangles that are in here, that center angle would be 36 degrees. So when I pull one triangle out, there's 36 degrees right here. But I have to cut it in half to get 18 degrees, so I actually can find the apothem, which I'm calling H here. They hide this triangle. I'm going to work with only this half triangle here. Okay, so 360 divided by 10 is 36. 36 divided by 2 is 18. Now I'm going to use this angle of 18 degrees to help me find out what this H is. I'm going to use a trig function. I know that tangent is opposite over adjacent, so I'm going to say that the tangent of this 18-degree angle, just this half angle here, is equal to the opposite, 3.5 over h. And remember that h is going to be our apothem. All right, so I'm going to solve for h. So I'm going to multiply through by h on both sides, divide by tangent of 18 on both sides, and that will give me h equals 3.5 over tangent of 18 degrees. It's calculator time. In my calculator, 3.5 divided by the tangent of 18 degrees will give me 3 decimal places, 10.772. That's my apothem. H is the apothem. So A is 10.772, and that's what I'm going to put in over here, 10.772 for my apothem. I already figured out my perimeter was 70. Throw that all in your calculator, and you'll have 377.02 units squared for the area of this decagon or tengon. All right, last guided practice problem. Now I have changed this from what's in the textbook to make it a little easier to make sense of what's going on here. This time we are given a circle, and inscribed inside of a circle we have a hexagon, a regular hexagon, and all that we're given is the apothem this time, which is 5. All right, first step, find the perimeter. Well, we're going to have 6 sides, so whatever the length of one side is, times 6 will give us the perimeter. To figure out what the length of one side is, we're going to have to pull this triangle out. Here I've pulled it out. And again, I'm going to need to find out the measurement of this little angle right up here. That's going to be half of the number of degrees of one of the central angles. There are 6 central angles, so 360 divided by 6 is 60. And then cut that in half or divide by 2, and then this little angle right here is 30 degrees. Now I can use that 30-degree angle and the fact that the apothem is 5 to figure out half of the side length. The side will be all the way across this triangle, and so half of it will be what I'm calling x. So the tangent of 30 degrees will be opposite over adjacent. Tangent of 30 degrees is x over 5. And I'm going to solve for x by multiplying 5 times the tangent of 30 degrees. So this little length here, from here to here, or this half a triangle, that is 2.887, carrying it 3 decimal places. And then if I double that, 2x, that's going to give me the length of one of the sides of this hexagon. So 2x is 5.774. Now I know the length of one of my sides, 5.774, 6 times. That's going to give me my perimeter. And then I'll round off to the nearest hundredth. So that's 34.64 units. So I have my perimeter. All right, my area, 1/2 times the apothem, which we're given this time, times the perimeter that we already figured out. So 1/2 times my apothem, which is 5, times 34.64 gives me an area for this hexagon of 86.6 units squared. So depending on what you're given, the apothem or a side, which we were given a variety of different situations in our guided practice. Here we were given the apothem and we were given the radius. We had to figure out the side. On guided practice 4, we were given a side, so we had to figure out the apothem to work out our answers. And then on our last one, we were given the apothem, and we had to figure out a side. So given the information that we have to work with, we will work out the unknowns, and then we'll be able to answer the questions about what is the perimeter, number of sides times the length of one side, or what's the area, 1/2 times the apothem times the perimeter. All right, that wraps up our guided practice. It's now time to move on to the homework problems and give these a try. We'll see you next time.